This is a past year exam problem that is an application of complex numbers. Pause this video to read this question. There are two parts to this problem. Part 1 is a proof problem on complex numbers, and Part 2 is a proof problem on trigonometry using Part 1. Let's start with Part 1. Since the expression for z is given in this problem, it makes sense to start with the left-hand side of this equation. So z is replaced by e j theta. Looking at the exponents rule, the first rule tells us that when we raise a to the power m to the power n, we multiply the exponents. This simplifies to e to the power j times theta times n, which is, in other words, next we use the Euler's formula. The Euler's formula says that the theta is taken by cosine and sine and written in the trigonometric form. We have cosine of the angle n theta plus j sine of the angle n theta, and so on. Now the negative angle identity tells us that sine of a negative angle equals negative sine of the angle, and cosine of a negative angle is equal to the positive cosine theta. These two terms are equal, whereas this is equal to minus j sine n theta. We're left with 2 cosine n theta as required. We have proved this identity, and we shall use this identity to prove the second trigonometric identity. What is not obvious, observation shows that if we let n be 1, we get z plus 1 over z equals 2 cosine theta. Therefore, cosine theta is equal to half brackets z plus 1 over z. On the left-hand side of the second identity, we get 1 over 2 z plus 1 over z, and the whole thing raised to the power 6. 2 to the power 6 is 64. So we need to expand this. By taking some time to expand, term by term, we get the expansion as this. You may use the Binomial Theorem to get each term. Next, notice that z to the power 6 can be paired out with 1 over z to the power 6. Similarly with the other pairs. Organizing them together, we get and from the first identity, we simplify this to 2 cosine 6 theta, where n is 6. Similarly, this is 6 times 2, which is 12, cosine 4 theta, and 15 times 2, which is 30, cosine 2 theta. Multiplying 1 over 64 to each of the terms, we get the result.